Hello and welcome one and all. Today we are going to cover how to test ETL pipelines. I have received a number of inquiries on testing and especially testing the data pipelines we have built using Python. Testing is an important aspect of ETL pipelines. It ensures that we are delivering accurate information to our stakeholders. We want to make sure our data is current, consistent, and accurate. If we perform no testing and we build number of tables, never knowing if something has gone wrong. In this scenario, the only way the problems will surface is via stakeholders' interaction with data. End users pointing out the inconsistency in our data is never a good sign. It erodes trust in the data we provide, and user will not feel comfortable using the data to make decisions. Therefore, it is a good idea to put test cases in place to catch data anomalies. A failing test can tell us that an assumption about our data is incorrect. For example, a column that we expected never to be null contains null values, or a column that we expected to be unique contains duplicate values. Testing can also catch flaws in our transformation logic. There are a number of other reasons we should include testing in our data pipelines. Testing ensures that we are providing accurate and consistent data to our consumers. Python has a number of testing libraries we can leverage. However, I will stick to Pytest and Great Expectations. Today we will cover Pytest. In the next session, we'll go over Great Expectations. Pytest is a general-purpose testing library where we can write our test cases and apply them to our data. Pytest is a command line tool that automatically finds tests we have written, runs the test, and reports the results. It can easily integrate with continuous integration or continuous delivery tools. Here are a few key reasons Pytest stands above many of the other frameworks. It has simple tests. Tests are simple to write in Pytest. Complex tests are still simple to write. Tests are easy to read, and we can get started in seconds. Let's open up VS Code or an IDE of your choice. The only prerequisite is Pytest, so make sure this library is installed on your system. We can install it with the pip install pytest command. In this folder, we will create a new Python file. Pytest expects the file to begin with test keyword. So we will name it test_pipeline_data_core. Along with Pytest, we will import pandas and numpy at the top. Let's bring in our data that we want to perform tests on. I have exported the data in an Excel file. It is available on GitHub. So we'll read in the AdventureWorks data from an Excel file. We are reading in the product tables data. We will define a series of test cases and we will run these against this data set. There are various types of test cases, but since we are starting from scratch, it is best to start by laying the foundation. We will start with the core tests that should be part of any data pipeline. One of the basic tests is to check whether a column exists in our pipeline. Let's say the product key column is expected to exist as we are performing transformation on it in a later stage, and it is used in the reporting that the end user consumes. Therefore, it is best to check if this column exists as we consume the data from the source. For this, we will write a function. The function name in Pytest must also begin with the test keyword. So we will call it test_call_exist. In this test, we define the name variable and set this equal to the column name, which is product key. We expect this column to exist before we proceed to the next stage in our data pipeline. Pytest allows us to use the standard Python assert for verifying expectations and values in Python test. Simply put, we declare a statement and then we check if this statement is true or false. So we use the assert keyword to check if the name variable exists in the df.columns. If this condition is true, then the test will pass. Otherwise, it will result in a failure. This test helps us prevent errors in our transformation stage, as well as preventing reporting errors in the reporting layer. Let's go ahead and execute our first test. If we are in the same directory as our code, then we can call the test with the simple Pytest command. I'll go ahead and bring up the terminal in the VS Code and enter Pytest and hit enter. This will find the test we have defined that matches the naming convention of Pytest. This will go ahead and execute those tests. We can also provide the file name after the Pytest, and that will also run the test against the dataset. Our test session has started, and it has found one test. Dot in this scenario means the test has passed, and we see the test results information in green text. If we encounter an F, that means test has failed, and the logs followed by it will be in red text. We should always test our primary key columns. And minimum, we should have at least 2 tests, one for uniqueness and one for the nulls. We use these columns to join our dataset to other datasets. These columns should never contain null values, and they should always be unique. Null values can produce unexpected results in joins and filter conditions. In addition, they can throw off counts and sums. So let's define a function to check for nulls. We'll call this test_nullCheck. Here we can check for nulls with the help of NumPy. We'll utilize the where method and check if the product key columns in our data frame contains any null values. In addition, we define a second function to check for uniqueness. We assert if the column values are unique with the help of isUnique attribute. Let's save our work and run all the tests with a Pytest command. This time around, Pytest found 3 tests and our assertions are correct, as all 3 tests pass. Another feature of Pytest is fixtures. We can define a function that we can utilize throughout our code. We can wrap our data import in a function. We define a function called df. In this function, we read in the data from Excel, and this function returns the df object. Once we decorate a function with @PytestFixture, the function is marked as a fixture. Going forward, any function we define will take df as an argument, and the df will come from this fixture. Fixtures are functions that can run before the test. Fixtures are used to feed some data to the test, such as database connection or input data. In this case, it will be a data frame. Let's go ahead and check the data types of our columns as our next test. Let's say if we expect columns to have certain data types, we can check the data type of columns with a Pytest function. So for this, we'll define 2 functions. We'll check the common data types, for example, integer and string. Our product key column should have a data type of int. So we can check if the column's data type is integer. Similarly, the English product name column should have a string data type, so we'll check this in a separate function. Let's save our work and test our data. We can check the results to make sure our data is consistent with our expectations. One of our tests failed. In this case, the product name column is read in as an object by pandas. And our assertion is that the data type of this column should be string. We can either convert it to string to match our test, or we can add in the additional check if the column's data type is string or object. So we'll add the latter condition to our test. Let's go ahead and save and rerun the test. Our test execution is complete and all of our tests are passing. Next, we'll check if our column values are in a range. For example, if you have an integer column and we expect the column values to be in a certain range. For example, in this scenario, we expect safety stock level to be between 0 and 1000. So we can check our assumption with a function. We utilize the between function and provide the left and right boundaries, which are 0 to 1000. Similarly, we can check if a string column values are in a list. For instance, the color column values are expected to be in the following list. We can check whether the unique values in the color column match this list. We get the unique column values and wrap them in a set and compare the set against the list of expected values. If both of these match, our test will return true, otherwise false. So let's go ahead and save the file with the newly defined test and run all the tests with the Pytest. It has found all the tests and our assumptions are true, as we can see that all of our tests are passing. If we have a failure, we can check the details here and we will need to investigate why our dataset does not match our expectations. In this case, all tests are passing successfully, so our data is matching our expectation, and we can be confident that we have set certain data quality standards and our data is matching them. We can further build on this to include more tests to catch any data quality issues. This is all on data testing for now. In the next edition, we will explore the Great Expectation library, and we'll see how can we automate all of this with built-in test. I hope you enjoyed the session. Like, share, and subscribe. Take care, and I'll see you in the next video.